webinar for reservoir field management and reservoir surveillance. I'm Hisham Mukhtar Ali, Senior Reservoir Engineer from Cairo, Egypt. So in this webinar, we will highlight very quickly the applications of reservoir surveillance tools and reservoir management and the software applications, one of the widely used software for oil and gas industry worldwide. So starting directly with our agenda today, the introduction to the integrated production modeling, the project administration and the project management for the production and field and reservoir data, analysis tools available for reservoir surveillance, like different plotting techniques, grid mapping, surface mapping, contour mapping, bubble mapping, and so on. Also, analysis of and data reporting. We will highlight some of the practical surveillance tools like the production forecasting, water flood performance analysis and surveillance, analytical mapping, then the some of the practical tools related to the bubble mapping, heterogeneity index, and then field applications, and finally conclusion. So starting with this very common definition of the petroleum production system. As you know, we have three main components of the petroleum system: the subsurface component, or the reservoir, or typically it's porous media, as you can see, which is we have specific reservoir parameters and specific characteristics for related to reservoir fluid and reservoir rock. And also the reservoir driving mechanism, types of fluids, how many fluids we have. Do we have oil, water system, gas, oil, water system, or gas, water system, and so on. Whatever the fluid system you have, we have corresponding driving mechanism and specific subsurface structure in terms of the faulting system and so on. Second and most important component is the well completion, which is defined by the completion and its related component. For example, the artificial lift systems and the completion string, downhole subsurface safety valves, and so on. And then the surface component related to the gathering system, processing facility, and pipelines, and so on. So this is the entire production system. So for proper and optimized analysis and integration for the total production system, we have to make a collective and integrated interpretation for all of these elements together to have optimization for the recovery efficiency. So as mentioned, the integrated asset modeling, IAM, is we have reservoir fluid simulation, well flow simulation, and network flow simulation to highlighting and understanding the interactions between all of these elements together to have optimized recovery efficiency. So as you can see, we have different disciplines integrated together in this process. So it's required to have good technical collaborations between different sectors and understanding all elements of the production system. This is the typically the different scales, from the field scale, microscopic scale, including the porous media with two main elements, the rock matrix and pore spaces. We have in this pore spaces specific combination of specific reservoir fluids, and for the integrated system analysis, we have to include the two common models, the inflow performance model to highlight the reservoir and the fluid analysis across the porous media from average reservoir pressure to the bottom hole flowing pressure. This is highlighted by this inflow model to a specific node. Second element is the flow for inside or through the production tubing or the outflow performance model. The intersection is the operating point for your well. So we typically search for how to optimize the production performance for that well, and how to design, how to plan for the next recovery step, like designing for the artificial lift systems and so on. So this is the typical field performance for highlighting 4 different phases from exploration to maturity phase. So we have, as you can see, in y-axis cash flow against time. So in the exploration phase, we have typically negative cash flow because we have more capital cost, capex, more investment for acquisition of the license, the seismic processing, interpretation, and so on. And once we have good potential, we can start the production, the exploratory drilling. Once we have successful exploration and successful discovery, the production will start somewhere right here. So we will start the second phase with the delineation or the appraisal phase to have more understanding of the reservoir extension, reservoir parameters, and so on. So this is the production build-up phase or delineation phase. As you can see, we have increase in the production rate. So the cash flow starts to be 0 at this payout time or payback time, and starts to increase at this point or this point based on the production, the development strategy of the field. Next phase, which is the most important phase, is the development phase or peak oil production phase, as you can see. So this is the major concern of our topic today, is the for reservoir management, reservoir surveillance, and monitoring of the production data and so on. So our objective is to extend this period as much as we can to have much more oil recovery during this phase. Finally, for the maturity phase, as you can see, the production rates start to decline due to the depletion of the average reservoir pressure, unless we have secondary or tertiary recovery development plan and so on. So our objective in that phase is to extend the field lifetime and delay the abandoned time as much as we can. So at the end, we have to follow the optimum development strategies that achieve the highest economic recovery and the best recovery efficiency. So this is the all elements of the production system, as you can see, including different types of wells, maybe natural or artificially lifted. Then we have the production is gathered as this production manifold, followed by the processing at the three-phase separator system. Then the oil will be diverted to next processing steps, or and finally to storage tank for gas. Gas may be used for gas injection, gas lift application, and maybe divert to gas export pipelines. Now we will highlight some of the applications of the OFM OFM is typically the one of the industry standard software for reservoir surveillance, reservoir management tools. So OFM simply we have the OFM project has two major components. The first one is the OFM, the Microsoft database or access file or access tables to be linked to the OFM, OFM interface file .ofm, but this one file .mdb or Microsoft database. So simply we have a database file like this access data file. All of the data, production data, will be stored in this database, as you can see in terms of tables, like this table, which is the master table for any project, defining the well names, X and Y coordinates for the wells, and also well data like well type, perforated interval, and so on. And second important table, which is a monthly production table, as you can see, defining the monthly production data or injection, or maybe pressure data, including oil, gas, water, and bottom hole pressures. Other tables can be defined, as you can see, related to the injection data like this. We have the water injection data, and other data related to static parameters like net pay, thickness, porosity, permeability, and so on. This is the first element of the project to store the data in this access database, as you can see in terms of table. Every table will be defined as a specific priority in terms of the recorded data. So the data may be recorded monthly, most probably like the production data may be recorded daily, may be recorded at different periods, maybe every 1 week, and so on. This is based on the frequency of data recording. Now back to this OFM software oil field manager. As you can see, this is the interface of OFM. As you can see, we have a set of tabs. The first important thing is to highlight the project setup, and we have an option right here to this is the what we call a schema table. In this option, we can highlight the link between OFM and the database. As you can see, this is the workspace file.ofm, and below this file we have file.mdb Microsoft database. So this is the important tables will be linked to OFM injection table, production table, including the production data, as you can see. So in this table, we have different data against date for oil, water, gas production, and bottom hole pressure, and so on. Other data like static data, like the field parameters, and so on. This is the some of the data linked between Access database and OFM. So once the data are linked in between Access and OFM, so we can use OFM features to analyze and to understand and to make different surveillance tool within OFM. So back to the slides to highlight one of the features to be available. So it's an integrated tool for linking the dynamic data to public database. We can define different workflows for well level, reservoir level, and field level. Also, we have features for production forecasting, reserve estimation, and depletion planning. candidate recognition, for example, to identify the best candidates for water shutoff and best candidates for stimulation operations and so on. Also, we have several tools for water flood management and optimization and so on. So the concept is to use the production data and field measurements related to maybe subsurface data like bottom-hole pressures, production data for wellhead pressures, and so on. Plus some of the diagnostic and analytical tools and finally we have to optimize the recovery efficiency for well level and even the field or reservoir level. So civilian solutions, we have tools for static mapping like volumetric oil in place calculations and drainage radius calculations, water management and water flood, like the analyzing the movement of production of reservoir fluids, unswept areas, permeability trends between wells, and so on. Production performance, typically analyzing the historical production performance for wells and even reservoir level for identification of the unswept areas. Also, we have some of the animation and time-lapse maps can be used to analyze and understand the changes in reservoir parameters versus time. Also, we have depletion analysis to quantify reservoir and their recovery efficiency and so on. So the solutions like identifying the candidates for hydraulic fracturing and stimulation, the water flood surveillance, and also well ranking to classify your wells based on the best performing wells and worst performing wells and so on, based on the well performance. For the low performance and bad performance wells, we can find solutions to optimize the production performance for corresponding wells. So analysis tools and applications, as you can see, the first data tool is the analyzing the production performance for the well level. As you can see, we have production data versus time and the production ratios like gas oil ratio, water cut, and the cumulative production, also gas oil ratio trends. This data can be analyzed on the reservoir level, field level, and also well level. Also, the analytical mapping for initial saturation, bubble mapping for the drainage radius for wells to identify the areas of unswept zone. Also, this heterogeneity index plot, like this, when to plot the heterogeneity index of oil against water to identify the over and underperforming wells. This is the just to highlight the wells we have low oil and low water production, like this wells in this part of the heterogeneity index plot. And also these wells we have high water and low oil production. This is the set of wells potential for water shutoff applications. Also production forecasting and conventional or maybe advanced decline curve analysis tools. So we have different tools, visualization tools like customized plots, animation, animated bubble maps, and so on, and grid maps. Analytical tools like we have several calculated variables, specific built-in functions, decline analysis, the pattern calculations, data normalization, and so on. Also, data management tools like linked table management and data linking to other software like exporting the production data to Betrel or Eclipse simulation routes. So the key features, as mentioned, the production performance tools and different levels, and we have to define the performance and measure the key performance indicator to identify the underperformers, analyze reasons for this underperformance behavior, and recommend actions for improvement and optimization, and finally monitor the production changes and results. So this is the typical production performance for every well, as you can see, and also already mentioned before. We typically have after peak oil production period, we have this decline period. We can analyze the decline data to predict the estimated ultimate recovery and remaining reserves. So back to OFM. So we have sort of the historical dynamic data and monthly production, monthly injection pressures, well events like completion and workover plugging data, static data related to physical parameters or maybe VVT data. Next is the all of this data can be analyzed on different levels using different types of plots, and also we can QC the production trends, specifically the production ratios, gas oil ratio, water oil ratio, and water cut. Based on this data, we can apply specific and make calculated variables based on the required tools. So we have different analytical mapping tools available in OFM. Let's highlight them now. So let's say you have this project. We have, as you can see in Home tab, we have the different analysis tools. We have this highly advantage feature in OFM. You can make line scatter plot, bar plots, and reporting, decline curves, type, well analysis, and cumulative distribution function, and so on. This is the advanced feature. The standard workflow, we can make different plot types. Maybe in OFM we have the facility to make, as you can see, up to 6 graphs in the same plot. For every graph, we have the ability to use up to 6 y-axes, as you can see. Let's say for graph number 1, let's click OK. So we have 6, as you can see, 6 graphs in this plot. For this one, we can define up to 6 y-axes for let's keep it as 2 y-axes. This is the for this graph. For every graph, as you can see, you can define the required parameters to plot, like oil production rate, gas oil ratio, water cut, and so on against time. This is the this feature in the plotting. Also, production forecasting for using the advanced and conventional decline curve models. Data reporting, maybe standard report or customized report. Grid mapping, we can highlight different types of map. Bubble mapping can be animated, and so on. So let's highlight for example, if we need to plot this let's say this regular plot, we have the production data for 5 wells, as you can see. In base map, you can find the the location of these wells. Also in OFM, you have the ability to make different customizations for all of this plot, like the grid and limits, grid setting, grid attributes, and so on. Map, legend annotations, headers, well annotations, and fonts, and so on. All of these parameters. So in all of them, as you can see, and if you go to format, we have 5 different plotting modes. The regular mode, you will, as you can see, you can display the production for different wells, like this regular trends for every well against time. So we can clearly identify the best performance wells are wells C4 and C3. But we have other options like stack the plots like this, so we can make stack for every well. That means the top curve or top well representing the total of the 5 wells. Also, we can find clearly and very quickly the highest contribution is for well C4 in green color, followed by well C3 in the red color, and the minimum contribution is for well, as you can see, C6. Another plotting mode like this is to make the summation for all of these wells using a single curve. As you can see, this is representing the total production of all of these wells. Also, if you use this option to use average, so you can display single plot representing the average for all of these average production for all of these wells. Also, in this option percentage, you can highlight if we have 5 wells and the to display the percentage contribution for every well. So, for example, the 3 wells in black color, C2, C3, and C4, representing almost 80% of the total production, and the next 2 wells, well number C5 and C6, representing only 20%. Also, the well C6 representing less than 5% of the total production, which means we have specific optimization plans for this well, like to look for the actions can be followed, for example, stimulation, hydraulic fracturing operations, and so on, to optimize the production for this well C6. This is the performance tool on OFM. Also, we can display the data, as you can see, using the different types of more than one graph in the same plot. For every graph, you can define which parameters to be highlighted. Also, we have another very important features for water injection. We have this one, which is the hull plot or hull function. So we can highlight the performance of water injectors based on the performance of this curve. So let's say we have this one. So the movement of wells to the left-hand side of this hull plot means we have specific injectivity problems, as you can see for this well in the in this well C6, while we have in the if we have wells in the right-hand side, if we have of these 2 wells in this C4 and C3, we have good performance, which means in terms of the cumulative, we have high cumulative for these 2 wells and low cumulative for these 2 wells. Also, we have other features included in OFM. We have highlight this. We can highlight the bubble mapping options. Also, in this project, we can display this important field plot, as you can see. So in this field, we have almost 230 wells. So the importance of this graph on the field level, we have the field, this is the data plotted for the entire field, as you can see, for all wells. And the green color, this is the this is the oil production rate, and this is the in the blue color water cut for the field level, and water cut is almost 90% at this period. And this curve representing the number of wells producing. So this is a good indication for the field performance, as you can see. So this is the total number of wells producing at this time. So initially, we have almost 2 wells producing at this moment, and then we can decrease the font size using this option. At this point, we have much increase in the total number of producing wells, which means it's significantly reflected on the production performance, and we have abrupt change in the oil production rate. And we have, from this point, we have continuous depletion in the and continuous decline in the oil production rate, as you can see. And at this time, we have stabilization in the average oil rate at almost 1,000 barrels, and the total number of wells is almost, as you can see, is almost. We have this option to show XY base. So if you click on this option, so you can we have this yes, we have this option to highlight how many wells. We almost have 20 wells producing in this period, and then we have reduction in the total wells producing corresponding to this drop in the oil production rate. This is an important field level surveillance to understand the field performance and understand the quick overview of how many wells are producing and the relationship between number of wells producing and the total oil production, and also the trend of, as you can see, of water cut and gas oil ratio. So so as mentioned, we have several plotting and analytical mapping tools, including bubble mapping, surface cutter mapping, and XY maps, and so on. So in every graph in OFM, you have the ability to use up to 6 graphs and up to 6 y-axes, and this is the 6 graphs in the same plot. And also we have in this we have 6 axes, as you can see, for the field level, highlighting different types of data in the same plot. Also, the plotting modes, as mentioned before, can be regular and stacked on maybe percentage to show the contribution for every well relative to the total production for the entire reservoir or the entire field, and so on. Also, we have another contour mapping tool to highlight the trends of any parameters like the water cut and so on. Structural mapping and grid mapping is another important feature, can be used to highlight the distribution of data like structural data, static data like, as you can see, like the distribution of velocity, and also we can make grid mapping for the time dependent data like water cut and the trends of the water cut, as you can see, and the areas of high water cut production and low water cut production based on this map. And also we can make this map to highlight the original oil in place, and accordingly you can identify the area of the field of the highest original oil in place or highest remaining reserve, which is maybe a potential for the next development and next drilling plans for this field. And here we have the oil in place or remaining reserve is minimum in this part of related to the red or orange color, and close to the blue color we have the highest remaining reserve blocks. Also we have another option, which is normalized mapping, the original oil in place minus the cumulative oil produced, which is the remaining reserve. Accordingly, you can identify the areas of low recovery and the areas of high recovery, and accordingly can plan for the drilling wells for that areas. Also, we have surface mapping like this to highlight the areas of the field with a specific parameter like the cumulative gas production and so on. Also, we have this parameter calculated in OFM, can be used to calculate cumulative liquid perforation foot to highlight the efficiency of your perforation. Accordingly, you can identify also the areas of wells that requires a specific improvement or specific optimization in the perforation efficiency based on the production performance. Another important tool in OFM, which is the bubble mapping. In bubble mapping, we can highlight and we can display bubble maps for single or two variables like this. And like cumulative oil and water production, this is a very important map to highlight the areal distribution and versus time of the production data for all wells, and accordingly you can identify the wells with high water production in this part of the field on the western northwestern part of this field. So let's highlight this feature right here in bubble mapping. So we have this project. Yes. So to display a bubble map for example, for this field, let's yes. In this field, this is the bubble map for two parameters. So the variables in this bubble map, as you can see, we have oil rate and water rate for all wells. In this, let's hide these annotations and also hide the frame and we can hide the grid. So in OFM, it's very flexible to make any changes and a customization in your OFM workspace, like customization related to the parameters to be analyzed and the customization of the generated maps and so on. So we need, I just need to decrease the font size of these wells, for example, using this band. You can select and assign the parameters for this map for every variable. So we have two variable, oil rate and water rate. For you can assign the colors for every variable, as you can see. But the important and powerful option right here is we can generate time-lapse bubble mapping, which is animated bubble maps, as you can see. So, and this is the data. This is the first ever well produced in this field, followed by some areas wells in the western part of the field. And this is the distribution of we have right here high water production, but here in this part, eastern part of the field, we have delayed water production in this part, but at almost here we have almost more than 90% water cut and water production rate. So we can understand the change of water cut and oil production, and also water oil ratio versus time using this animated bubble maps. Also, we can display bubble maps for example, for the cumulative oil production, let's say as a single variable. The interface of OFM is typically like the Office interface. We can double click to expand this workspace area. So this is the bubble map for the cumulative production. So this part of the field representing the highest cumulative production, and this is the number of wells. Simply we have different zooming options like this, as you can see. It's very flexible to zoom on the wells, and can display how much cumulative production we have for every well. This is the well name, and this is the cumulative oil produced in this is the units of cumulative oil production, as you can see, and this is the date. So it's very flexible to understand the field trends and the production data for the well level or reservoir level and so on. Similarly, you can make at the time 0, which is the start of production at 1971. We have the legend right here. Let's yes, this is the cumulative oil production. So let's zoom on this area, for example. So similarly, you can run the animation and monitor the changes in the cumulative production versus time. So at this time of the field, we typically have no more wells producing, but let's at this time let's stop the animation. In this part of the field, on the eastern part of the field, we have start of production in these two wells with high cumulative production. If you click continue animation, so we have a rapid increase in cumulative oil in this section, followed by this part. As you can see, the western part of the field is still not producing so far. So we have, and this is the teams. We have the this well with the highest cumulative production. This one, and you can stop animation at any time, and can zoom. Let's say for this part of the field, as you can see, this is the typically one of the highest, the best wells with the highest cumulative production. You can fine tune and make more reliable analysis of your data, for example, using plots. So you can make a plot for, let's say, select as a variable for all wells, add multiple curves. And let's say we need to display the cumulative oil. This is the variables, calculated variables in this project. As you can see, you can make calculations of different variables like oil rate, liquid rate, water cut, and so on. So for the also this is the gas oil ratio cumulative. Yes, this is the cumulative oil production. This is the variable. We need to display cumulative for oil production for all wells, which is 158 wells, and click OK. And click OK. So now, yes, this is the cumulative oil production of all wells. Let's keep this legend away. So it's you can also customize the y-axis, for example, to change the scale. The minimum is negative 100. Keep the minimum as 0. Yes, so it's very clear. We have this is the highest, the best performing well in this field, as you can see, and you can clearly identify the wells of high, good performance and low performance, and so on. This another features that can be highlighted. So there's unlimited tools and features available for data analysis and production surveillance and reservoir management. So we have this calculated variable editor to make unlimited number of calculated variables. Also, we have this catalog, which means we have set of tools can be used for different surveillance. As you can see, let's yes. So the tools right here are organized based on the operations. So we have general surveillance tools like the water cut bubble mapping, cumulative production ranked reports, ranking the wells based on cumulative production. The water flood management tools like the hard plot and so on. Water flow analysis, also the SAGD or steam assisted gravity drainage operations, and so on. This is the different analysis tools can be generated in the interface. So also we have this as you can see, water control diagnostic plot to analyze the performance of water. Let's highlight this well, for example. So based on a specific templates or specific type curves of the water oil ratio and the water oil ratio derivative, we can identify the issue for the water. Is it water peaks through, water channeling, water regular and conventional water movement, and so on, based on this plot, water control diagnostic plot, um, as per water oil ratio and water oil ratio derivative, and the fitting of the data for every well, so the time actually is not available to highlight all of these features in more details, but just I'm highlighting one of the common tools. Also, due to the time limit, we have another powerful decline curve analysis tool. Let's say and if you go to Home tab, we have production forecasting tools. In production forecasting, we have this plot. Let's say we have this one. So this is the production. So in this well, as you can see, let's yes, this is the well production performance and decline analysis. So we have in OFM we have different decline curve and production forecasting tool, like the empirical harvest approach, Vitkovich, or advanced type curve modeling, and so on. Let's say for this well, we have, this is the production data versus time. So, and the flow modeling can select the parameters related to the phase for the production decline, maybe oil, water, gas, maybe ratios like gas oil ratio, water oil ratio, water cut, and so on. Also, we have to define the cumulative production and oil rate. And for the forecasting model, we have different models based on the hyperbolic exponent B. So we have three common models: exponential decline, hyperbolic, and harmonic decline, based on the expression of Arvis equation. So let's select the exponential decline. So the hyperbolic exponent will be 0, and click OK. In that case, in the property span, as you can see, the decline rate can be manual, monthly or yearly, nominal or effective decline rate. And for the history matching, we have exponential decline, and this is the best fit for the exponential decline. Once you select the exponential decline, you have to make proper fitting of the data using this straight line tool. As you can see, you have full control of this tool to define the start and the end of the straight line. And let's decrease the font size of this legend. Yes. Yes, and this is the results. So as you can see, and we have this model matching the data using exponential decline, and this is the end of. Let's back to this this slide to define this the one of the important terminology in for the decline curve analysis. So in all of them, as you can see, using the conventional decline, this is the end of history, which is this is the history matching using a specific model like exponential or harmonic or maybe hyperbolic decline. So the cumulative oil produced at this point is defined as the NB, or cumulative oil production. And at the end of history, this is the predicted and forecasted oil production. Accordingly, you can, this is the prediction period, you can calculate the what we call EUR, or the estimated ultimate recovery, which means it's in the cumulative production at this point plus the remaining reserve according to specific economic limit. So in this legend of the results, we have the hyperbolic exponent be 0, which means we have exponential decline. The decline rate is this is the monthly decline rate. It's 0.008 fraction per month, can be displayed as fraction per year and so on, as per request. And so this is the decline rate. And the remaining reserve, as mentioned, this is the forecasted volume. And finally, the estimated ultimate recovery EUR will be the remaining reserve plus the cumulative production. And accordingly, you can save your forecast like this. So this is the saved forecast for this well. Accordingly, you can make several scenarios for forecasting to generate like forecasting like this, to generate forecasting with low estimate, best estimate, and high estimate corresponding to B90, B50, B10. B90 means it's the remaining reserve at 90% probability, which is more conservative estimate. But B10 is the remaining reserve at at the 10% probability, which means it's an high or low degree of confidence for the estimates for this well, and so on. This is the due to the time limit, I have to stop at this point. Before this, I need to highlight this important feature in what we call the the heterogeneity index plot. So the heterogeneity index plot, let's make highlight this plot. So it's loading the total wells in the project. So this is another feature in OFM. Simply the principle is let's highlight right here. It's a powerful option and powerful tool to compare the performance of a specific well relative to the group average of all wells on the same reservoir, for example, or same field, or same fault block, and so on, to identify the wells of high overperformance and after performance based on the heterogeneity index parameter. It's for example, for oil, the oil rate for this well relative to or divided by the average group average of all wells producing in the same reservoir minus 1. That means we can classify wells based on this heterogeneity index. So if heterogeneity index equals 0, that means the wells behaves like average, higher than 0, above average, which is good, less than 0, which is negative, it's in below the average. So you can classify your wells based on this scatter plot. So for this example, we have the production heterogeneity index. These wells we have, as you can see in this heterogeneity index plot of oil and x-axis against y in heterogeneity index of water and y-axis. So So as you can see, this is the origin or the intersection. We have positive and negative part of the plot. So this wells means we have high oil and high water production, which means high liquid. But these wells we have, as you can see, oil in x-axis, we have high oil and low water, which is the best performing wells. But the group of wells in this part of the plot means we have low oil and low water, which means low liquid production. It's typically related to the productivity issues or formation damage, which is they are good candidates for stimulation or hydraulic fracturing and so on. And these wells, they are high water and low oil, which means they are candidates for water shut-off operations and so on. This is the powerful one of the, another powerful features in OFM. Thank you so much. That's all I have in this session. So feel free to ask any questions